Okay, we are here. I hope all of you finish Unit 9. We will start by architecture, pattern, and reuse. First of all, we want to discuss what's mean by the reuse. ما المقصود بكلمة reuse? Page down. Reuse in general, people, here, think about something like what? Like, for example, I am creating, مثلا, let me just write it here. Think I am creating, why the color is white? Change the color to red. Think about I am writing a function called sum from 1 to 10. In, for example, project 1. This is my function. Next time I need to create a function, I want to submit a number from 1 to 100 or 1000, we'll say, like that, for project 2. So if I take, for example, in this, I will say 2 weeks to finish the job. So here I will take only maybe 1 day. That is what's mean by reuse, because this function is already there and I already write it and I know how the structure of this function will be done. So my job, it will be more easy and it will be more quickly. So this kind of concept, we call this is a reuse. When we are doing something like that or following some concept like that, we are avoiding the duplication. And instead of duplicating myself or duplicating the work, so here I am just using something, it's already there. So I am saving my effort. So here I'm avoiding duplication and saving my effort, and the job is already there. So just I will make a little bit of update. Think about if I'm using for statement. So instead of writing the for from I equal 1 unless I أقل من 10, so I will use from I equal 1 I less than 100. So that will be very easy. A promote reliability. That means if I understand this summation is work perfectly, so I can depend on summation from 1 to 100. It will be also reliable and people can work on that. Speed up the development, as I told you here. If I take in the first summations creation 2 weeks, so for the second one, because I already know the job and I know the basic and everything will be ready, so I will take only 1 day. So that will make my development more easy and more quickly. Number 4, mechanism for spreading good practice. Good practice means if I'm using this submissions for project 1 and it's worked perfectly, so if I need the same for the same function here, I can use it also in project 2. If I need this, also I can use it in project 3. So that will make the mechanism is very speed and very practice instead of repeating writing the code of submission operation from number from 1 to 10. So like that, we think about the advantage or the privilege or the benefit of creating a use of software engineering. So this concept is very useful, is very helpful. It's avoid duplication of the data, make our effort less, saving our time, make our development more faster than what we know for the last previous decades. Think about when we are creating a reuse on different levels. So we can have a reuse in, we have a reuse in anything, we can do a reuse for idioms, for design pattern, for the architecture, for the analysis pattern, for the requirements pattern, and for the software component. Think about requirements pattern, it will be more easy to understand. If I am creating a software for, if I'm creating software for health, for, we'll say, which king will say, what is the name of the hospital? We'll say Sulaiman Faqih. For example, I am creating some software for them. I will say software 1. After I finish this, we'll think about, we finish that after 2 years, for example. After I finish that, next time, Moasa Hospital, they came to me, I write it, hospital. They came and asked for another application, another software for their health. So the first software I take 2 years. The second software I can finish in 6 months only. Why? Because I will reuse everything. I will reuse the requirement. I know I understand the software of the health department. I understand how the patients will join the application, how they will create the data. So everything will be clear for me. Same concept. It will be the same in the analyzing the data. It will be the same if you can use the same architecture. If it will be the same if you are using the design pattern and the idiom. It will be a little bit of change if they have a little bit changing, like for example, they are if I complete مثلا 1 year in Sulaiman Faqih, they will give me discount for one next year. If they have something like that, so there will be a little bit of change in creating your software. Otherwise, everything you can reuse it, everything you can do it again. So it will save your time and it will save your effort. Okay? Is that clear, people? Do you have any question? If you have a questions, please write in the chat room. Next, we'll speak about what's meant by the architecture. We have different kind of architecture design in software engineering. Software engineering is something like software developer, like building a houses. You can have different of style. Think of you want to build a house. You want to build your house, maybe you want 5 rooms, 3 bathrooms, 2 kitchen with 2 floor. This is my house. Another one, he will want to build his house with 2 rooms, 1 kitchen, 1 bathroom. So this is will be different kind of architecture for it will be different from each and every software. So what is mean by software architecture? Software architecture is the structure or structures of the system which comprise a software element, the externally visible properties of those elements and the relationship among them. So that will be think about I want to design my house, how I want to design it. So this is I think this is again right. Think about me, I want to design my house, how I will do that. Say this is my house here. It's a green. No, I didn't want this. I did this. And say I want, for example, 2 room here. Why you are giving me this? Okay. طيب. People, delete. And delete. We'll just draw it like this, better. This is my house. Think about it. I want 2 room. I want my kitchen here. Just write K. I want 1 bathroom here. I want one biggest hall in this area. So this will be the structure of my system. The structure of my system, how I will move from this room to this room, how I move from this room to the hall. There will be doors related to this, and I have the door of my house. So think about the software is something like that. For each and every house or for each and every software, we have different structures. It will be depends on, and they will be having different elements. So we need to know how we will make a relationship between among all these elements. So that's what we call an architecture of our software. Okay. Here we have different level of structures for the software system. For the software components, think about your software. I say I have a room, I have a kitchen, I have bathroom, I have a hall, I can put مثلا a gym rooms, I can put a playroom for the kids. So here my component in the software will be different. It will be I have database, I have applications, I have services, I have protocol, I have connections, I have a web server, so I will be putting my component like that, and I will create some structure if you see the structure here. So you have to make them organize and you have to make them connect to each other. So we will see here. Here I have a client. I have a backward. I have a client here and a client here. This is my data or my database. So to make everyone access this is data, this is my structure here. I will say the client can send connection to the data, and the data will be notified to the client. Same for each and every client here. So this will be the relationship among my component. Okay, is that clear, people? So that is called a level of structure of the software system. It should be organized. Organized means if I return back to my home here, I cannot put a room, for example, with no door or with no window. That's not acceptable. So here, when we are creating this such kind of structure, you have to make sure each and every component, they have interact with each other. If I write this component, if I write system like that, this is my client and this is my server, and I didn't put any relationship between them, so this is not well organized. I have a problem in my organizations here, okay? Here we have different, I think we have 9 different architecture style. We speak about them in chapter 9. So we have a data flow architectures, and we have a notification architecture, service-oriented architecture, peer-to-peer architecture, client-server architecture, call and return architecture, layered architectures, and data center architecture, and in the independence component architectures. We'll go for each and every 2 for them. Here, just we put all of them here, you will see them together, and you can compare between each one of them. So we'll go for the first 2. Here we'll see for the notifications level, architecture style, we will have a component sending a request to the subscribe certain. So I will just see the drawing here better. You will see, think about, you want to publish a paper. So you have to, as a client, you have to register first into the publisher website. After you register, they will send you update. We already accept you as a person or sign in or one of our customers. So your registration will be valid now. You will subscribe to sending your paper. I want to send my paper for publication. So this is, I'm creating a new item. Whenever they put my paper into review or something happen into the status of my paper, they will keep updating me until the last time they will say, for example, your paper have been accepted or your paper have been rejected. So I think that is called a notification. People like مثلا a football. Now we have a lot of application. If you are busy, you can register on them, and it will notify you if, for example, if I am one of Real Madrid fans. So I want to know what's going on during the player. So they will keep sending me notification whenever anything's happen. So like that's called a notification system or a notification application or style. If you want to create something like that, it should be the structures like this. You will have the client, and the client, each client should register first into the website or into the data. Then they will keep update him about what is going on or what is happening news. Or you can register, like think about BCC news. You want to know the news every what happened new. So they will keep notifying you by updating each and every news happen in the world. So like that, we'll have the component. They have a good communication with each other. So here we'll have the notification system. The second type is called independent component. The independent components means I have different kind of process. This is a process and this is a process. They will be depends on each other. So this process will send the message to this. This process will send the message to this. This process will send the message to this, and they will keep doing something like that, something like a circle. So that is called a message mechanism process. So they will independent of each other. If anything happened to these, this system will be crash. So here I have 2 type of architecture, the notification and the independence component. These 2 are clear for all of you. Do you have any questions until now? If you have a questions, please write in the chat box. People, where are you? Are you sleeping? I didn't hear anything from any one of you. Do you? Okay, someone is replying. Good. Thank you, Hanan. We'll go for the next architecture. The next architecture are two, the client server. This is the third one. And the call and return structures. A client server, most of us, or we can say all of us, we know how this is work. It will be organized like this, depends on the organizations, and it will be have a connection as a client. So we will have one server here. This is our server, and this is our client. So this is client one, this is client two, and this is client three. Each and every client, think of us in Arab Open University. This is our server or the LMS or the SIS. We as a client or a faculty, we will send a request to the server. Then they will evaluate, this is my name, my username, password. Then they will respond back to me by whatever I ask. So this is the relationship between two components. The connection will be in the two sides. It will be request and response. This is a very basic structures. Most of the organization now, they're following these techniques, a client-server architecture, because it is more suitable and more clear for everyone to understand how the process is going. And it will be more centralizations. We will have all the data for all the faculty and for all the students and for everyone related to Arab University. It will be in our server. This kind of architecture, they will have a problem if the server have been crashed, so we all cannot have anything to do. So that is, it's a basic and it's good, but it's also have their own disadvantage. Okay. The fourth type is a call return. Call return is also, it's an organization's technique. It's also following call functions procedure. So here we have a caller and we have a callee. A caller, what we'll call? A caller, it represents the part of the system that has a task needed. So I am the caller, think about me, I am the client. A callee is a component that contains the functionality I want to execute. So here, as a caller, I will send a request to the callee. I'm asking for something. They evaluate and process my data, then again send me the response back here. Think about this triangle here. This period of time, this is the time I need to finish my job here into this process. So I have some part of the work here and some part of the work here. This is not a vice, this is a vice versa of the client server. The client server, everything should be in the server. Here, as a callee, as a caller, I have something to do. And as a callee, they have some of the part of the work should be doing into them. So here, this is called a call return architecture. This is a traditional structures programming. These days, most of the people, they are not using this technology. It's very traditional technique structures programming. So this is what we call a return. So here we have a client server, and here we have call a return technology. We'll go for the fifth one, is data flow. What do you mean by data flow? You can get from the name of the architecture what is mean by data flow. You will see here the data is going in this way. This is how the data are. So you will have some data here running into this pipe. You will apply some filter. So I can see this is filter one. It will run through another pipeline. I have another filter here and another pipeline and another filter here. So by the end, I will get some data here, filtering by 1, 2, 3 filter. That is always happen when we have something. Think about data analyzations. Data analyzations, we need to have our database here, for example. We want to apply some filter. Say, for example, we want to remove the empty field. So this will be the first filter. We can see here in this filter, we want to remove a students, their age less than 20, for example. The third filter, we want to remove the student, they are not part of Riyadh Center. So like that, my data, it will apply different kind of filtering. Then by the end, I will get clean data here. So this is kind of architecture style, but this is a specific design. It should be, like I told you, this is always happen when we need to build something like data analysis application. Such something like that, we follow the data flow architecture. Okay. The sixth type here is a service oriented. From the design, you will get some idea about the service oriented. The service oriented, think about this is as a channel, an open channel. Anyone can interact with this channel. You see here client one, client two, or customer one, customer two, customer three, customer. So here I have 1, 2, 3 customer. In this channel, I have two provider one and provider two. A provider such as a supplier. Think about my provider like someone give me, say, internet. They put the internet, think about STC and mobile. They will put their internet in the one biggest channel. We as a client, we connect to this channel and take our services from here. I will identify myself as a STC client, so I will get the information from STC. I will identify myself as a mobile client, so I will get the information from mobile like that. So that is called a composite of the services, which are discrete piece of functionality. The service communication is a lightweight, so this is called a protocol of service oriented. This kind of protocol or this side of techniques is very rare to use. It will be need for specific company. They want to share, مثلا, a specific pipeline or a specific area, say to minimize the risk of damages or to minimize the cost of building a new one. So that is called a services oriented. Is this two are clear for all of you? The data flow and service oriented. Do you have any questions? If you have a questions, please write in the chat room. Yeah. Okay, good. So we'll go for we are 5, 6. We here 7, 7 and 8. Here we have a peer-to-peer. We shortly say P2P. A peer-to-peer is very organized techniques with a good connections, but a little bit weak. The peer-to-peer means each and every client here or machine here can be work as a server and a client at the same time. So this X and this Y, we can say just 1 and 2 instead of X and Y. One can send a request to the 2. 2 can reply by response for the 1. Vice versa, 2 can send a request to the 1 by replying the response for. So they think about they are servicing each other. Both of them, there's no centralizations here. So the difference between peer-to-peer and client-server, all the data will be in only one machine serving everyone. But when we go for peer-to-peer, we have different client and different server, they are serving each other. The benefit of the benefit of using client server is if this having all the data, you can secure the data here into the server. And the disadvantage is if this crash, this system will be crashed. For a peer-to-peer structures, for these, if this machine has been crashed, so still the system have been running because this machine can act here or can ask here or can connect here. So there is no problem here. But to make this kind of system more secure, I have to secure all the machine, the 5 or the 6 or the 100. So that will be a difficult job to handle. So that is how the peer-to-peer technique work. It is each and every machine here or each and every component work or not work as a client server in the same time. So that is avoiding, that is if you didn't want to centralize your data. We'll go for the 8 structure style. This is called a layer. You will see from the structure, you will have something on top of each other. We will go, this is the bottom layer here. This is the top on it. This is the top on it. This is the top and this is the top on it. So this is the top layer, the first one here. And this is the bottom layer, the last one here. In between, you will have different kinds of layer. The benefit of this layer, each and every one, they will be interact for the top layer only. So here, if I am here, say I will just put 1, 2, 3, 4, 5. The benefit of these techniques or this structure, layer 1 can talk to layer 2. Layer 2 can talk to layer 3, but layer 3 cannot talk to layer 1 until they will go through layer 2. So think of that. This is sometimes it became a benefit, sometimes it became a disadvantage. If you need, if your software need a layer, a specific layer, I want only this layer to connect with one and two, so I will go for this kind of structure because like that I am preventing the other layer like 3, 4, and 5 to speak to layer 1. I will enforce them if they want to access layer 1, they have to go through layer 2. So this can consider as part of the security or part of applying, preventing your data. So think about, I can put all my data here in layer 1, and I will create the username and password and everything. Anyone who want to access the layer should come through layer 2. So like that, I am having a more security into my data. So this is called a structure, our architecture style, the layer style. This is number 8. Is that clear? Do you have any questions, people, in these 8 layers? We'll go for the 9 one, then we'll see. We don't have a 9 one. Okay. I think there are 9 was. Okay. So do you have any question here in the notification or independent component or client server, all call and return techniques? If you have any questions, please write in the chat room. Okay. Thank you. Here, just we mentioned some example for a layer. Think about a layer like a stack on top of each other, or like a plate. If I have something like that, I will put this is layer 1, this is layer 2, this is layer 3, and this is layer 4. Compiled in Java programming, which executes Java virtual machine, that is term make call services supplied by operating system. A client architecture design in which there are just 2 layers and connected to each other, take from request and response. So that is just explanation for the client server, and this is explanation for our example for the layer. Each layer will be used service provider by the layer below. So that's what actually we explain here. So 1 can access 2, 3 can access 2, 4 can access 3, and like that. Here we want to say about in data center architecture style, what is the difference between database and blackboard? A database, you will see here a data center architecture. Here In A, this is a database. In B, this is a blackboard. So what is the difference between these two? The two are form of data center because you see here, this is my database, and here, this is my database, my blackboard. If the communication is always initiated by a client, so I am a client, I am initiating the accessing for the database, the store simply respond to request. It is called database or repository. That is here. When store average, which the store is active, inform user change so that the communication may be initiated from either end, is turned a blackboard. So here you'll see just the difference between, you see here, this line and this line, and this line is not there here. So here in the database structure, the client must initiate the request, and then the data will respond back to him. But in the Blackboard structure, the client can initiate the request, and also the database can initiate some request to the client, and the client must respond to that. When we have this kind of relationship in both directions, so that is became a blackboard. So it will be a little bit differentiation. It is not that biggest. The basic idea is there. I will send a request and you will give me response. Here we have some example from Unit 9s for each and every client server. That's why I mentioned there are 9, why there are 8 there. Data flow, data center independent, or I counted trunk. Okay. They will say what is the architecture style of. Okay. Here we'll say that this is, they will give, think about this is for مثلا a question exam. They will give you some style differentiate explanation here. So we will read it together and they will select the architecture style. You will see, we'll read the first one. Different division of an organizations whose system all use a common set of services, such as payroll, personal, customer, records, management, billing, and so on. So there are too many of services for each and every client in the organization. So that will be a service oriented. RSS feed. RSS feed, that means I have feed, that means I have to get some information or notification. So that will be a notifications design. Streaming music service. I want all hear a music for the most of the time. So if any one of the clients have been deleted or I cannot access, so that I can go for peer-to-peer. Unix operating system for combining functions. That is a different data should be going through different filter so that it's a data flow. This example is coming from our slide, but we just take them out to make it clear for you. And that it may be also an exam questions. They may bring something, some descriptions of the architecture like that, and they will tell you, give the specific architecture should be applied for this design. A stream applications programming interface, that is API, this is data flow. A Java Swing event handling code, that is notifications. Method in object-oriented programming, that is called return. A compiled Java program, this is a layered. A web browser to a web browser, this is a client server. Here more, a BitTorrent, this should be peer-to-peer. A blockchain, this should be peer-to-peer. Image processing application, that will be data flow, that is related to data science. Stock trading application, should be notifications. I want to know if some product have been deleted or have been finished from my store. An email system, that will be as most as a client server architectures. So here we have how many examples? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's good. We have more architecture style here. Processing data through, no, process data through a series of transformations, each component processing input data, that is data flow. An operating system That is structure and layer. That is when you see the layer, it's definitely a layer. An application where various component subscribe. When you see subscribe, you will go for notifications with no hesitations. A traditional applications that start a main method and proceed with functions call that return back to the callee. So that call and return, when you see the word call and callee. A software application that consists of plug-in additional feature where each plug-in operates and can be added or removed. So that independent component, you have to go back and remind yourself each one of these 9 architecture style, what is the benefit of using each one of them? So you have to understand the compromising between each and every one. What is the advantage and what is the disadvantage for each and every one? We stop in web services, ecosystem where services are provided to other components to applications. So that's service oriented, the protocol. Web applications where browser request information and central service provided, that's client server. A file sharing system where each participant can act as both client and server, so that will be peer. When you are reading, think they always give you hint about the specific architecture. So you, as a student, I advise you just to print this paper without the result and try to figure out what is the main keyword here, show you which architecture you have to decide. Okay? Is this example all clear for all of you? Do you have a questions until now? يا رب لك الحمد والشكر. Okay. Here we'll have a question exam. Compare the layer and the pipe and filter architecture and provide an example of where each architecture can be used. This is 8 marks question. So you have to give a 2 definition. The first definition for the layer and the second definition for the pipe and filter. A layer definition is layered style when a system is structured as a series of layers that are visualized as stack on top of each other, and each layer communicate with the one directly above or directly. So for this definition, either you understand it from here, this is our layer. You can use the word that's already there from the slide. They will give you specific details and specific definition. In the exam, if you feel you cannot give the exact definition, you can just try to explain clearly what is the layer definitions. Pipe and filter, the definition will be the pipe and filter style is when a small independent subprogram, a filter, process a stream of data and pass the result through a pipe. And so if you give the 2 definitions correctly, you will give the half mark. Here they ask you compare. When they ask you compare, so you have to give some differentiation between both of them. Suppose you can see some similarity and some, at least you can give 2 similarity and 2 differentiation. Suppose here they will say for pose architecture are similar in way that each layer a subprogram function independently and service data from another layer or subprogram. You can give an example because here they will say, here they will say provide an example of where each architecture. So example of layer architecture will be Java virtual machine or any operating system. Example of pipe and filter will be Unix and operating system or Stream API. You can give a different example if you are sure they are using the layer and they are using the pipe and filter. Don't just give any example and say it will be correct. If you didn't use the example here, you have to give a correct example and make sure your example is related to the specific topic. Okay? Here another example for an architecture. They will give a scenario or descriptions for a company. We will read the scenario together. A company decide to build an open music share system. When you hear open music system, because we already see that in the previous, so that is coming our side, and it should be a peer-to-peer, because here we see file sharing can be post client to server is given peer-to-peer. Again, here in this example, when they say peer-to-peer, streaming music service, it should be peer-to-peer. So we can put some information in our mind like that. So we will read the question like, company decide to build an open music share system where people can stream an audio track from other user by sending requests, and then each user system would either start streaming to a request or would forward the request to another user. If the request cannot be fulfilled, a software engineer decides to use the call return architecture, comment on whether the architecture selected is the ideal choice or if the completely different architecture style should be used. Make sure to justify why. They will tell you the software engineer here decide to use call return architecture, so they want your advice which is better. So a call return architecture is not, you will see, is not suitable for such services. I advise or I suggest a peer-to-peer architecture. Why? Because much better since audio streaming will occur between peer and there is no need for any record keeping or synchronization communication. Good. This is a good explanation. Is this question and the answer is clear for all of you? Do you have a question? Do you have a question for the question? يا رب لك الحمد والشكر. Yeah. Okay. طيب, we have an example like this is a view I told you. Architectural view, which is called Kitchener 4+1 model. We'll have 1, 2, 3, 4 model. The logic view. Here we speak about the view. We speak about the style before. Here, this is architecture style. Here we will speak about the architectural view. So for the view, we have a logic view, process view, physical view, and developmental view. A logical view that is consider how the functionality of the system have been provided. What is the details need from the user or from the client to create a good software with high responsibility, functional well, do the job. A process view, it will be deal with the performance of the system, how the system will be, is it security, quality, scalability, usability, dependability, flexibility. So that is a process view. A physical view that will be described the system deployment, how the software is mapped to the hardware network. When I finish my software, how I will install my software into your machine. Do I need specific operating system? Do I need a specific machine? Do I need a specific details? Something like that. A developmental view, that's how we will organization the software system and how we will create our module, how we will select our structure. We will go for peer-to-peer or client to server or service oriented. So here we have the views. Think about the view is like this. When from the beginning I told you I want to build my house. A logical view, that means have be structures like that, just a drawing, simple drawing. I want 2 room here or room with bathroom. I want, this is a garage. I want a hall here. So this is logical view. How I will process my view, that is, I want it to look like that. The view I want is like that. Where the physically I have to build that, I have to select a land, I buy it and start putting this is a tree, my view will be here. Physically, my house will be in this area. A developmental view, so that is I am starting developing my house. Finally it will look like that. This is a very clear and simple example related your module. The first step will be logical view, the process view, then the physical view, then the developmental view. Is the architecture view is the 4 module is clear for all of you. Do you have a question? Okay, so we'll go for the pattern. What's mean the pattern? The definitions of pattern is in the software engineering is a design pattern describe a relatively small, well-defined aspect or the functionality of a computer program in the term of how to write the code. So a pattern is something like how we will make our software engineering well-defined. What does mean by well-defined? That mean the system is working functionality perfectly. So this is the definition of the pattern. We have 3 types of pattern categorizations. The first one is a creation pattern. The second one is a structural pattern. The third one is a behavior pattern. What is the differentiation with each one of them? You can get from the name of the pattern. Creational pattern is creating the object from scratch, or the object is not there. So I have to make something from the beginning of my design. I'm starting something, it is not there. It is a creating object of the client that will use them. A structure pattern, that's mean I'm building the relationship between my classes. So I will put them in specific structure and I clearly explain the relationship between my object. Who will send the message, who will receive the message. So that should be clear to each other. A behavioral pattern, that is how they are communicate and interact to each other. So either I will go for create object or creating the relationship and make the communications between my object. It should be very clear. That is what we call a pattern. Is that clear for all of you? Do you have a questions in the pattern? If you have a questions, please write in the chat room. Okay. Here we'll see something called a catalog of design pattern, how we will create our pattern. We will create our pattern like, think about creations pattern, an example of factory pattern or skeleton pattern. A structural pattern, think about the adapter pattern, which we discuss in this chapter, or MVC pattern. A behavior pattern is something like the observer pattern. So we'll go for the first one, a creational pattern. A pattern is something like, think about this here. You will see here red, blue, red, blue, red, blue. So this is for the circle. For the square also it become red, blue, red, blue, red, blue. So this is the same pattern with a different shape. Here we'll have red, blue, red, blue. Here another pattern here. Here we'll have red, blue, green, yellow, red, blue. So the pattern will be in between other classes. So the pattern repeating the pattern, that is a common occurring of the problem in software design. That it can be applying a similar problem in different contexts. So here I'm going red, blue, red, blue. Here I'm going red, blue, red, blue. Here I'm going red, blue. I put green in between. Again, red, blue, again, green. Here I'm using something different. I'm saying red, blue, green, yellow, then again red, blue. So you can put different pattern here, focusing in different design. It will be look like each other, but they are different. So typically we'll focus on a specific aspect of the software, such as object creation, behavior, and collaboration. So that's what's mean by repeating the solution for the same pattern. The architecture is a higher level design that describes the overall structure of the organization system, and it will be defined the major component and their relationship between each other. Here we have to concern with the big picture, how the different parts of the system fit together and design functional. So when you see this picture here, how this is fit to each other. Is it look good or it is look bad? Or we can make a little bit of changing into these architectures here. Okay, so here we'll have the pattern and we'll have the architecture. We have to put a relationship between both of them. The pattern is how we are doing our processing. The architecture, how we will describe the high level of our design of this system. So here we will concern with the biggest picture, how the different parts of the system fit together, or how our components will be putting on each other to building our architecture. Okay? Okay, so we'll go for unit 10, that is building block and enterprise architecture. I don't think all of you start unit 10. I'm not sure. Okay, just we'll take a break for 10 minutes, then we complete. Okay, can you please confirm me that everyone finish chapter 9 and 10? People with all your faculty. Where are you now? Just write in the chat which the last chapter you finish. I hope you all finish 9 and 10, or you at least finish 9, you next week you'll start 10. Okay, okay. The rest of you, I'm waiting for you. Can you please tell me in the chat room, where are you now, in which chapter with your faculty? 10, okay. And can you tell me how many activity you finish until now? Okay, just make sure all of you finish the 8th activity before the end of the semester, and make sure you contact your teacher to finish the activity. If you have any work or you are absent for something, this is very critical, people, and we are running off the running by the end of the semester. So please contact your teacher to make sure you complete all the activity and your teacher giving you everything and your class and everything is done. Okay? If you have any problem, please, you can contact me by email. Okay. We didn't want to hear anyone that he didn't take the activity or he didn't attend the activity or there's no marks for them for the activity. So please make sure you contact your teacher for that. Okay, thank you. Okay, so we are completing our class here. We stop in the component or building the block and the enterprise architecture. That is in unit 10. We reach only with unit 10 and unit 11. This will be the last unit, inshallah. So unit 10 speak about what's mean by the component. Simply, we want to describe what's mean by the component. A component is something like that. It's a unit of functionality that designed to serve as a part of system or the application. Think about anything. When you are building a sign-in component, when you are building a push button component, when you are creating an image, that is considered a component. So you will see here a different sample for the component. This is sign-in component. This is an image component. This is account component. This is a login component. So each and everything into your software, we can consider that as a component. So simply, we will have an example of component on our page. So this is an alter bar, this is component. This is a hair bar component. So we have 1, 2, 3, 4, 5 components here. Each unit of these, because each one give me different functionality and different job, and it should be part of the system. A component cannot run alone out of the system. Think about, this is my component here. If I put something like that, this component cannot work alone. It should be connect with another component, and the whole system will be all of them. It should be something like all of them like that. All of them should be in a system. So when I have more than one, we think about 3 or 4 or 5 or 6 components working to each other. So now I am building a creation of the full system. But when we want to define for each and every one, it's that it will be only one unit having a specific functionality. Think about you as a student in Arab Open University. Think about the registrations process. The registration step we can call creating a button for you called a register. When we are creating that button, we are designing the functionality of the registration of the student to make that functionality work perfectly with our system. We cannot put a component of registration. It's just like that without of the blue, without make the interaction with our system. That cannot be done. Is that clear? What's mean by the component, people? Do you have any question? We will think about the component like anything in the software engineering. When we want to design here, when we are studying M251, we design the classes and the interface and everything related to UML, which is Unified Modeling Diagram. The same concept we will follow here. When we want to design our component, we want to build an interface for our component. So for creating the good interface or the good application building our component, we have to make several different interfaces because we have several jobs here. For each and every component, we have two kinds. Either we have a provide interface or we have a required interface. So either we have provide interface or we have required interface. So here I am drawing the component. It should be something like this square with this symbol in the right area here. The small one should be like that. It should not be a black box or empty box. The box should be like that with this symbol in this area in the right corner of the box. If you have any services you want to provide it, you will draw this line or this shape like this. So that's, we know this is an required interface for your design. If you want to provide any interfaces, so provide interface should be in a circle. So here I have 1, 2, 3, 4 services here provided by this component, and they have two required interface here. So I have 1 and 2. It should be 1, it should be 2, it should be 3. There's no specific confirmation here, or it must be. Either you have 1, 1, or 2, 2, or 2, 3. That will be depends on what kind of software you are building. Maybe you are building a healthcare system. Maybe you are building an education system. So it depends on the variation of the software you will create or you will design your interface and the required interface and your provider interface. Do you hear me now? السلام عليكم ورحمة الله تعالى وبركاته. Do you hear me now? Okay, alhamdulillah. That's good. Actually, we're about to finish, but it's okay. Fine. From when you didn't hear my voice, because that's mean you missed something. I'll just repeat the component from the component interface. Okay, here for each and every component, what's mean by the component? I'll just return back here. The component is mean each and every bottom here in this website. So the component definition is a unit of functionality that is designed to survey as part of the system or the application. So if you see in this picture here, we have a logo component, a sign-in component, an image component, and creating account component. So we have different design for the component. Think about the component is something we cannot act alone. Let me just remove this. Think about this is a component for a registration in Arab Open University. This component cannot work alone. This component should have a relationship with creating a schedule, finishing your payment, finishing your exam. So like that, we are creating a system to make a full system by having all of them in one set or one of software. So like that, we creating our system. In this example here, they're giving us different components. This is 1, this is 2, this is 3, this is 4. 4 of them or 5 of them, they are working together here to building the software or to building this website, making working together. But if you take one by one, the one alone cannot serve alone. This one cannot serve alone. This one cannot serve alone. So both, all of them should be together to building our software. But if I take one of them, I'm speaking about the functionality of this part, about the functionality of this part, about the functionality of this part, I like that. Okay, here we want to design the component using the UML structure. When we have a UML structure, we have to design the box like this. This is our box for the component. In the left right corner here, we have to put this symbol, and we have to put the required interface by this design if we have more than one interface. If we have any provider interface here, you will have a circle around like this. So here I have 1, 2, 3, and 4 provided interface. It should be 2 or 3 or 1 or more. So that will be depends on what you need. So that will be different from software to another software. There's no specific, it should be only having on one interface or one provider or something like that. Here we have two ways to design the graphical component. Either you will go for a graphical design, which is this part, or a textual design, which is this part. Both are correct using the UML Unified Modeling Diagram. When we want to go for a graphical design, you will just design the component in the box like that. The right corner, you have to put the graphical stereotype. Then you will have to put an I provider and the I required. You have to make sure that is the I provider is a circle round and the I required is these symbols. Either you will go for in the middle of the box, you have to write the name of the component, or you will go for a textual design. You will see here that is look like the UML structure when we are building the class, but for the class, we put something here, the third part. Here we'll put the name of the component. Here was, if we have a properties, we'll put here. For the component, there's no property, so that will be not here. The second part here will be the operation or the functions of our component. And you have to mention clearly using the stereotype of component to show that this is a component, and clearly the stereotype of provider to show this is the provider and this is the request. So I have 1, 2, 3 important things to mention here. In the graphical, it should be clear when I'm drawing the circle and I'm drawing the this symbol. Is that clear, the differentiation between the graphical and the textual? Do you have any questions until now? Here we'll have the example of two components act to each other. We have one component for the account and other component for the security. And this is a basic concept running for each and every application. Whenever you are joining any application, you have to give your username and your password. Your username and passwords, they will be encrypted, so they will take them as your account and check that you are part of our system, or you are part of that account, or you are registering into that application. Then only they allow you to enter to the system by checking you are giving the correct username and the correct password. So this is just an example for a management accounting system interface, how it will work and how it will be accessing each other. Make sure when we are creating the accounting here, we have this is only as a provider, there's no interface here. And here we'll have the provider and the interface, the provider and the interface. So it will be like this, and it will be the interface like this. So make sure when you are drawing the relationship between two components to decide which one is I require and which one is I interface. Is that clear, people? Do you have any questions until we go for the next example? Do you have any questions until now? Thank you. But we have here another example. Think about two components. We have X component and Y component. In this example, they try to explain if I have X and Y can replace X and X can replace Y. So that will be vice versa. If you want Y to replace X, that should be having the same knowledge and the same design, and that should be designed by contract. Think about the assumption will be made by Y must be same that made by X. Because if I want to replace X instead of Y, so if I have, this is my system, and they have X here, and this is another system, for example, and I have Y here. For any reason, X is not working, so I want to remove X out, and inside I want to put Y. So I want the same functionality and the same technique and the same design because my system otherwise will be crash. So in this concept, think about like, for example, your faculty. Say you have two faculty, you have Ahmed and you have Muhammad. Both of them, they are teaching you the subject TM354. So if Ahmed is absent, Muhammad can take his class. If Muhammad is absent, Ahmed can take his class by the same quality and the same explanation for the same part. So like that, Ahmed can replace Muhammad and Muhammad can replace Ahmed. So that's what we say. They have the same knowledge and the same design. So they can accept the replacement of X by accepting Y. Is that clear for all of you? Do you have a question in this example? يا رب لك الحمد والشكر. If you have questions, please write in the chat room. We'll go for the next example. Here we have some explanation about the search component. Consider this is an example for questions. Think about, consider a search bar component. A component is an e-commerce system that has a precondition only performance search if there is a query contain at least 3 characters. So I have to write 3 characters at least. And the post condition that's guarantee at least one search result if match exists in database. So here we have to assume and guarantee. Assume that is the client will give me something. So as a provider, guarantee that I will give him result from my database. So component D can perform a search for any length of query. Also guarantee at least one search must exist and provide enhance of the filtering of the result. So we have two components here. We will have component A. We have component A and we have component D. Both are, can we replace A with D and Y? So the first component can allow me how many characters I have, at least 3. This is A. Component D can perform search for any links. So now they will ask me, can I replace A with D? So the answer will be yes. The component D can replace A. Why? Because D is bigger than A. In A, I'm searching only 3 characters. In component D, I have any time I can search for 5 or for 6 or for 7, any links. So which is bigger? D is bigger. So D is bigger. Inside D, A. A is smaller. Normally, the bigger one can replace the small. But if you ask me the vice versa, A cannot replace D, but D can replace A. Is that clear, people, why I can replace D by A? Do you have any question? Consider about yourself. This is a question in the exam. Can you answer that clearly? And do you understand why component D can replace component A clearly? I will ask the vice versa question. Can component A replace component D? Can you tell me the answer, yes or no? And give me a good explanation. Can I make A instead of D? Is that work? People, are you sleeping? Okay, okay. That's mean the answer here for when we having A, it's give me only 3 character. By D, it will give me very long of character. So I cannot replace D by A because this is very short and this is very long. So here, if I replace, that's mean I will stick only for the 3 character. So because A is weaker than D, it cannot work. But because D is more stronger than A, so that it can be work. So here, the stronger of the both condition, that D must at least fulfill the basic of both condition of A. Okay? Is that clear, people? We'll go for another example. Briefly identify, think about this is an exam question. Briefly identify 2 advantage and 2 disadvantage of the approach known as CBD, component-based development. So you have to clearly mention the advantage and the disadvantage. I think I have 4 or 5 advantage and 4 or 5 disadvantage. But if you are sure from the 2, you can just write the 2. If you are not sure about the 2 you write, you can give just 3. We will select the best 2 of them. So for the advantage here, they will say cheaper to reuse, quick to development, and have been working in many projects. For the disadvantage, they will be restrict for a system. There will be additional work for the software needed to be done. That is coming in the table. If you all remember that we have one table like that, they will write advantage here and disadvantage here. I think they are being 5. For the disadvantage, the adapter might be need incompatible component, and it is not easy to put a plug-in component into a software system. Okay, is that clear for all of you? Do you have questions? Okay, if you don't have any question, I think we will stop here. See you next master session, inshallah. Do you have any question? Just be with me for 1 minute. I will take your attendance. Thank you for all of you. Download